Hi guys, I hope you're good since last video. So you've seen this sample of an AI song. So probably in the future we won't need any more human stars. We will be just making our own personalized songs. So in this video, what we're gonna see, we're gonna use FreeCAD to make a 3D object, very simple one, and we're gonna use Agent to make this object and prepare it for 3D printing. So that's what is interesting here, is that you're going to get a file that is ready to be 3D printed. Alright, so we're going to jump straight away into the architecture. So how is this organized? Let's start with the user. The user prompts description of a 3D object to be printed. This goes to a kind of guardian, which is going to check for impoliteness, harmfulness, and just check the prompt and also reformulate the prompt using LMStudio Extra 7B. So if there's a danger signal, we just warn the user that the account is on hold and there will be a human check. So this is the role of the guardian. But if it is okay, it's just gonna reformulate the prompt and send it to the agent, the coder agent. The coder agent, which is gonna be executing the script using FreeCAD Python console. So it's gonna make the script, execute it, and save it in a folder using the FreeCAD Python console. After that, after having executed the script, there will be a .stl file that will be generated. So this is the agent tier with the tools powered by Grok. So this is the external LLM. So everything in the middle, it's all the agent using Grok. So it's fast actually. So the STL file will be saved into a folder. There will be a slicer agent. It's going to copy the STL file to a watchdog target folder. And after that, when we get this in the watchdog target folder, you'll be able to detect that there is an STL file, and it's going to start the slicing job using a slicer. And the slicing job saved, it's going to save a G-code file in a special G-code folder. So here we could just straight away maybe take this one here and detect it from this folder, but I just created another folder having a tool in the middle with another agent. So this can be simplified, or you can add more agent if you want to do some more different processes. And after, the user can get the G-code 3D object layer file and print it. Right, so this is the software and services tier on the top. In the middle, we've seen we have the different agents using Grok. And down there, we have the file system. So the slicer, the coder, and the guardian. And here we have all the different folders, file system tier. Okay, so this is for the architecture, very quickly. So the video doesn't last too long. The potential improvements, maybe a notification service that tells the user that the file is ready to be printed. Automation, with a user 3D on 3D printer automatically printing it, but I don't have any 3D printer. Next to me, so incorporating of a paid LLM API service like OpenAI for more complex shapes because here we're using 7B parameter models, so it's pretty hard to make complicated shapes. We could also implement a converter. So as I told you, you can add some other agents which are going to make they're going to make different jobs, and this job here would be maybe to check the STL file, to convert it to a PNG file, and to have a human just by seeing the PNG file, understanding if the shape is the right one or not, if the object is the right one, because those agents, they can hallucinate. They can also lie and say that the job is done, everything is right, but it's not actually. So yeah, so seeing the image of the 3D object or the incorporation of a vision LLM also. So you can also offload that by using a vision LLM. So I believe that using paid services, you can get it more consistent and have a human notified with the interpretation of the image. For example, so receiving an email or Slack notification or anything like that to say that the job is done. So installation, you need to install Grok. You will need to install FreeCAD. So here I've just used the app image just to make sure that FreeCAD is working in your computer. So here we're just going to extract everything using the suggestion. Here we just extract everything, so we will have access to the FreeCAD binary file. It should be an app run file. We're just going to test it, try it, see that it works, and after keep going. You will also need to install Langchain for the tools. If you want to customize the tools, if you want to have more edge. But we're going to use a solution that has everything already incorporated. So the code that I'm going to show you in this video, it's going to be a bit having parts that I'm not using because I'm just extending the code. I wanted to try different things, but we'll go into the details later on. We're almost done here. Some other parts of the video are going to be fast forwarded, but the part concerning the agent making the object, this part is not going to be fast forwarded, so you're going to be able to judge and see how long it takes, if it is acceptable or not. Okay, almost there. This is done. So that's where we get the binary, the apparent file. Let's just reorganize this. Okay, so I can get rid of this now. The squashfs root folder. Now we should be able to try the app run and see that FreeCAD is working and is running. So I might put it later on into its own folder to have it more organized. You need to install LMStudio and get it running. So I'm not gonna go through all the installation of LMStudio because I have many videos in this channel showing how to install it. But you need to have your models linked. So I'm using an external SSD drive, and we will be using Mixtral 7B from here. And in this new, just to show you the path here, that's my mount in the Linux machine. I have a Vision LLM, Java, but I'm not going to use it during this tutorial. So the video is not going to be lasting for 3 hours. You would be using the playground and loading 2 models, the Mixtral one, and the other one is the Java one. And at this time you'll get 2 models here loaded, and you'll be able to check the image at the end, the PNG image. Install Crew AI, so that's the solution with the tools. Having the agent team, I'm going to just fast forward some parts of the coding parts. And we're going to start the code review. This is the first part of the code review. We're going to do the second part with the main application code. So what do we have? Just keep in mind the architecture. And we're going to go through all those files. Watchdog layer slicer. Target the STL file. So let's open it. It's in the terminal, just here. This is the second one I'm going to show you. And this is the check if STL is present or not. So here we're using Watchdog. Doing those imports, sub-processes. So this is going to work on the side, waiting. So we need to launch it at the beginning. So this is the STL folder. This is an initialization of the observer. And after the handler, it's another class which is down there. Even handler. That's the one here. And after we set that directory to be watched, so we don't need recursive because we just have the files directly into the folder. And after every 5 seconds, it's going to be checking. If there's any error, we're just going to stop the observation. And we're using the sub-process here to do the check. So if the event is directory or not STL, there's nothing happening. So if I put a PNG file inside, there won't be anything happening. But if it is an STL file, at this moment, it will be printing, received, created event with the path, full path of the STL file. And after that, you just implement your function, which is slash file. That's the function that we implemented using the slicer tool. Just going to format this the path the output file where we want it. We want a G-code file. So we're changing the name from STL to G-code. And the folder is going to be in the G-code folder. Okay. So that's just for the naming of it. But that's the command here, which is going to do the job of slicing using slicer. It's a subprocess. So the layer 8, the field density, the different parameters that you can set. This is a minimal slicing command. And the output file that we want. And the file path is going to be the STL file. So after we start the process of slicing using the command, standard output, standard error, text to true. So the return code 0 means everything is alright. Slicing complete, successful, and we give the path. And if there's any error, we just print the standard error and the standard output. We print everything, the return code and everything. And we handle the error in the exception. Just to see what is the error, if there's any. And after here, we just run the watcher, which is on the top. The first class that I showed you. So this one here. So this is for the check if STL file is present. So this is the watchdog. I'm gonna have a little break here. Please like and subscribe, and we're gonna go into the longest part of the video, which is the main code review. Main LLM agent application code review. At the end of the video, we're gonna see what's gonna happen. There'll be a little bonus at the end. So we're just gonna do some imports that we need: Longchain, Grok, Crew AI. So I did some extra imports, some extra LLMs, but you set your LLMs from your environment variables. And after you set the topics, here the topic is the user input. We're going to check the user input using LMStudio. We load the Mistral 7B model, and after we put in the message that it needs to check if it is harmful or impolite. If the user is harmful or impolite, he's just going to put in his answer Shibuya danger. That's a kind of secret word. If it is not harmful, it's gonna reformulate. It's gonna just prepare this prompt for other LLMs to understand it. And after here, the user say check if the user request is harmful or impolite. If it is not, you can proceed. And after here, that's where we're going to precise what is the version of FreeCAD also. Temperature is set at 0. So here, if there is Shibuya danger in the response, we're just going to put the account on hold. We just here send a message. We raise an exception. And after here, we set up the tools for the agents. So this is the code executor, but that's not the tool I'm going to use here. I've set many tools, so we're going to use one tool. This is called the script creator. Script creator has this doc string. This creates a FreeCAD script and execute it in the FreeCAD console. So the LLM can read that script. Grok client, that's what we're going to use, and the system prompt. You can pause the video to read in detail all those prompts, but basically what it says, it just gives instructions, 7 steps here, instruction to make the script. So to not put any libraries that doesn't exist, to use Markdown also for the output. So make sure that the code is saved where the user requested it to be saved. The indentation also. Sometimes there's issues with indentation. So going through the libraries, the indentation, not to explain the code or give links, just not to be too talkative. We just don't want the extended answer. We just need the code, and we precise that it's for FreeCAD Python scripting. And after we just put the topic here, so the reformulated question. Here the temperature, I've set it to 0.1. And for the token, 1024, the max token. Streaming is false. And after here, we're going to pass the answer just to get the code. So we split at the markdown mark, and we get rid of Python also. There's going to be a written pattern here, as you can see. That's how it is formatted in Markdown. And we get rid of all spaces, leading spaces. And after we're going to write this code to a file. And this file will be able to be executed. So in the next one, we use the subprocess. Import it. I can import it at the top, but I import it here just to make it to understand what's going on where. Sometimes imports are too far away from what we do in the code, so we're using the FreeCAD console here and applying the script. The binary, we're asking for the console, and after we applying the script, same. In the subprocess here, we get the standard output, standard error, and if there is an error, so exception while processing file, if this is in the standard error, at this time we're gonna actually use that to call the LLM again to fix the code. Because I realized that the first code is not, if you call it just once, you can get it right straight away, but sometimes it's not. So we need the code to be fixed at least once. So the agent is called just once, not several times by the manager. And here I'm just getting this standard, the output, the error, and sending the initial code that has the error to the LLM, providing different steps in how to debug the code. And the other instructions are the same as before. For the indentation and the libraries. And after that we get the code fixed. Same, we're going to pass it, and after we're going to save it to a file. We're going to write it to the same file, so replace that code. Just add the debugged version on the top, so we know that this is an iteration. That's the second code that we got saved. And after the command to fix it, applying it to the Python console, because what we want is to execute the code and to get the STL file downloaded, so the object. So, and after we handle the exceptions. So we're using a try except, so we handle the exception here, if there's an exception. Return the exception. So to create this tool, you do the function, as I did now, and after you use here the structured tool. So function, you're just gonna say what is the function, the name of it. We put it here, and after we put the name, so I put the name for everything. And after you put the description, this is very important because that's what the LLM is going to read to choose this tool for the task that is going to be asked to perform. And I'm telling him that he must use this tool. And this tool is to create a FreeCAD Python console code executable and to execute it and get the 3D object downloaded as an STL file. Execute. There's some typos, but it worked at the end. You can also have arguments. So here, same, you need to use a class for that. It's commented out. I tried, but I didn't need it. But you need to use the base model and create this argument. I have some other tools here to check the file presence in different folders. But I'm just going to use one with the agent, which is just to check if the STL file has been downloaded. We have another tool here, is the slicer, automatic process. So this tool will start the process of slicing the 3D object into layers. That's what the docstring says, and I put the command here to do the copy. Because you copy the file from the agent STL folder to the target folder where the watchdog, the code that I showed you before, is waiting to start the slicing process. So here, same, you use the structure tool from Longchain to make this tool, and you provide the description. So function, say what's the name of the function, the name of this tool, and the description. You can use also human tool if you need it. I tried it, but I want a full automated process with the human just checking at the end. So I didn't put it into the process. So here we have the coder, the agent definition. So I'm just telling him to use the script creator tool to execute it. To have the FreeCAD Python console, creating the 3D objects, and I'm just giving him some instructions to not create his own code, because that's how normally you use CrewAI. It makes its own code and it's going to be delegating that code to another LLM. But here I'm just telling him that the message at the end of the tool, so the return message will be the most important part, because the message is going to tell him what to do. So you're an expert, this is the background, just telling him that he's an amazing expert in FreeCAD Python scripting. Okay, and after the tools that we use here, we use the script creator tools, and we use the STL agent file check presence. Delegation, yes, we use the Grok LLM. Max request per minute, and the iteration is very important to set. We have the slicer agent here. So the slicer agent, same, I'm telling him to use the slicing tool to create the layer of a FreeCAD 3D object. And same here, I give him instructions to not create his own code, because he's going to start hallucinating, he's going to start doing some repeated cycles. And I'm telling him that he's an amazing expert in slicing. And we have the tool here, slicing tool. There's no delegation here. We put 5 and 3 requests per minute. And here the crew, create script task, all the tasks. So here the first task is to make the script and to get the STL file downloaded. Responsible, we always put the topic, so the user prompt back to those descriptions to refer to it, because the agent doesn't know anything about about what's happened before. So you always need to reference all those parts. You need to check the available tools and to perform the task. So keep repeating this. In these videos, there'll be a part in which I'm gonna just quickly show you what are some of the issues that you can find using those ones. So this is, for example, a return message telling him to check if the STL file is present and start the slicing process. So the output of the function is just telling him what he needs to do next. Or there will be an error message also. So you see here, I'll just show you the agent again. Because here I told you, so do not block the work if you believe it is best. You must use the tool to fulfill user requests. You see I keep repeating, you must use the tool. It's very important to repeat. So you have no choice, you have to do that. After those ones I already showed you, all the different ones. So let's go back to the task, slicing task. Okay, so we got the prompt, check available tool and use those as they are already set to perform the task. The return message from the tool will tell you what should be done next. Okay, and the expected output must be a return response from the tool with a success message and next step to be done or an error message. Okay. So after we're done, we just arrive to the end here. We just put all the different components together. So let me comment this out. Object modeling team. And here we just kick off the project. We start it with all the tasks and the different agents and the manager here. The process is hierarchical process with the little verbose of 2. Alright, you've been patient, that's good. So let's review quickly issues. So some issues, as you can see here in the screen. It happens that the agent will just be repeating himself. So just producing the same output indefinitely. So the manager issue also. We don't have much control over the manager. So sometimes I find him not clever because he could just stop this process maybe. Or have maybe a count limiting it. And also the LLM using the same tool several times. Okay, so let's have a break here. FreeCAD LLM 3D printer. Let's start the app. Python agent 3D. What 3D object do you want to print? I miss a part in my artwork. I need to print a 3D cube. Let's give it centimeters with 23 centimeter sides. And after we wait, so at this time, this prompt is sent to the Guardian. The Guardian is going to check the prompt and it's going to return us the response. So the app can stop now if I put really bad words, or the app can just keep going with a new prompt, a little bit reformulated, more precise. So now it's running, it's allowed, and now we have the agent starting to produce some code. It's pretty quick, as you can see. can maybe review the output. Just wait a few seconds. So maybe let's go back to the top. You can see there's some debugging happening. Entering a new chain. Here I'm prepared to just ls to check this folder. You can see here the code has been produced. We got the STL file also downloaded. That means the execution went well. And we got the script saved. So now the slicer should be taking that STL file and putting it into the watchdog folder, the target, for the slicing process. So this one here, Agent.stl, should be going here into the STL folder, where we have launched the check if STL is present or not to start the slicing process. So that's another process running, the watchdog one that I showed you at the beginning. So we have to wait. So sometimes it needs time to review the tools that it has. But here we can see that the tool has recognized the path. And now starting to slice using the slicing tool. I would use the slicing tool with the following input. So in my slicing tool there's no arguments, so there's no input. But that would be the right input. That's good. So here I'm not fast forwarding, so you can see the whole process, how long it takes. And what's going on in the background with those agents. So here the max request per minute is reached. It's very important to have those limits set, otherwise the Grok API might send you a 429 limit request reached and give you maybe tell you how long you need to wait. You can implement in your code also retries, exponential retries, but it's better just to set those limits, especially the limit that makes the LLM repeating himself, just to stop this cycle of hallucination. Okay, you see he's gonna start going back into the process because he couldn't do the slicing process, so restart it with the coder. So at the moment he's trying to reproduce, to create a new code. So this is part also of the issues that you can have. Everything was right. You were almost at the end. Only one step left. But the team just decided to go back and restart at the beginning because the last agent couldn't use the tool, couldn't understand the tool. But here I'm using it in a way that maybe it's not the regular way to use it, but it works. Because the agent is expecting to use the output of some other agent and put it into the function. But sometimes I realize that the formatting is not right, so you're just getting errors and errors. So you better have control into the code process and you just use the agent to activate that process or to not activate it. And this time they use the intelligence to judge if they need to use it or not. Okay. It's not gonna last very long from this time. You've been very patient, that's good. So here the thought, now that the coder worker has created and saved the 3D cube STL file, I will delegate the task. Slicing tool. Again, we're back to this step of slicing. The request per minute, the maximum is reached. So same here, we need to wait. This is just an example in red here showing you the description that we put for this tool. It is outputted here. And the slicing process has started. That's good. So you see, the watchdog could identify this STL file and start the slicing process. I can provide the final answer. 3D cube has been successfully sliced into layers. Keep sliced. Okay, it says where I can find it, but it's not where I can find it actually. It's not the right path. But as I control it through the code, so it can hallucinate on his outputs. But we got the cube.g code file. So we arrive at the end of the process here. The script created the kubestl has been copied to the watchdog folder. The watchdog folder have detected that file and have done the slicing process. And at the end, it's just stopped the chain. Has been fulfilled because at the end I said that if the slicing process goes well, the agentic work is done. So we are done now with that. Agent code verification. Did they actually do the job or just slide? As this also happens. So this is the code that has been created. You can see on the top we have the debugged version written. So this is the right path. This is the name of the file. The name of the file, the agent decide what the name is. We just give it the path. And here we get the FreeCAD code to make this cube, and the download has a STL file. So that's the code that has been executed, the last one. So what can happen also is that you get a code executed, it's the right one, you get the STL file, and after it goes back again in another loop, but the next code coming is not a good code. But the STL file has been downloaded, so the next agent can still process the work. Let's just review the STL file very quick. This is the agent STL, that's the one that has been copied. What is inside this file? Is it just a fake STL file? Is there any object? Seeing that, I think this is a cube. I can tell. No. Just we're gonna check that later on. So this is just random numbers. You can't understand, you don't know what it is. The G-code file, quick review. So the G-code file is the file that is the one that can be used in a 3D printer to create the object. So this one here seems like to be a cube, a 3D cube. but we're going to check not this G-code file, because I'm not going to 3D print it, but we can convert maybe the STL file and check how it looks like. We're going to convert it into a PNG file and see if it is actually a cube, the conversion of FreeCAD STL file. Let's do the conversion of it. So this is done, STL to PNG check. And here it is. That's a cube. So the Agent team have done a great job. That's the cube that I asked, 23 centimeters for each sides. And that's the bonus, the file converter called the review. So we're using the Python library called the VTK. We create a reader for the STL file. And after the mapper, for the data, you see all those numbers that we've seen before. So we set some colors to have a contrast, so to be able to see the object. So here is gray. And after we set the background to white, which is 111, we create a render window. The azimuth. So after here we work in the angle in which the object is going to be turned. To be able to see that it's a 3D object, even if it is a 2D PNG. Okay. And after render, and we create the window, the image filter to capture the image, and we create the PNG writer. Right. I hope that you liked this video. Please subscribe and like, and see you next time.